All right, here we are, guys, with our this is our March paper this year from 2021, and we're looking at question paper 6.2 and question number 5. That's the first of the physics ones. Let's go for it. Exciting one this time, I think we all agree. We're looking at methods to determine the maximum volume of liquid that a test tube holds. All right. As soon as we see test tubes, we start thinking about meniscus, about non-uniform shapes, etc. Okay, because this is definitely going to come into our work today. We've got two methods. Okay, the first one involves simply measuring the dimensions. Okay, so we're going to use a ruler to measure the diameter of the test tube. My diameter I measured of 1.5. The answer scheme gives 1.6. As usual, folks, scaling factors, printing issues will cause you to have a slightly different value to the mark scheme. Do not worry, okay, if that is a different value. Okay, now we'll do the same thing for the length. Okay, kind of intrigued by quite how different my length is from the answer scheme. It's normally only a couple of millimeters out. Okay, but again, there's slightly different values here. Do not worry about that. The main thing you need to make sure you're doing is following the instruction, which is to give it to the nearest 0.1 centimeters. Okay, so again, in this example, I measured mine as 12. Okay, well, I've written it there as 12.0. Okay, and this allows me to show that I'm measuring it to a higher degree of precision. So please remember that each time. Okay, we'll go for it looking at our values here. We're going to use our value D to calculate the volume, and you're told the equation. So in this case, remember, paper 6 is assessed at core level, and that means that they will give you some equations. Okay, gets a bit nastier at extended level. Okay, now what you'll find here, okay, is that your values, again, because D and L may be slightly different to the mark scheme, you will get a different value of the volume. If you notice mine, my volume is a lot smaller, okay, 21.33. However, all I need to do is use those values and make sure that I'm following the instruction to give to two significant figures. Okay, so what that means is ignoring this 0.33 and giving just 21 centimeters cubed, and that's going to be later. Okay, we're going to end up doing something with that a bit later on. So make sure you always follow that. What I like to do, or I like to encourage my students to do, is always to write down the value to a large number of significant figures first, and then round it to the significant figures requested in the question. Okay, we've got method 2 now. Slightly different. We're going to pour water into a measuring cylinder. We're going to record the reading. We're going to fill up the test tube with water and then record the new reading. So essentially using a kind of almost like a semi-displacement method here. Okay, we're being asked to measure some values. Notice here we've got a meniscus, that's that curved surface, okay, which is a bit of a leading thing for us to come onto here. We're going to try and make sure that we pay attention to that later. Recording the reading, well, if we've got 80 and 70, 10 divisions in between, so this one just lower than 80 is going to be 79. Here, 50 and 60, 2 lower than 60 is 58. Okay, and again, look at that, 2 marks for simply reading the scale, all right? Come on, guys, we can do this, all right? Determine the maximum value of the water that a test tube can hold. Well, what we're doing there is we're using the fact that we started with our 79, ended with 58, and we got 21. Okay, so actually, interestingly, my two values give exactly the same answer. Not something we're going to worry about. Okay, suggest a possible source of inaccuracy. Okay, why might those that method 2 be not very good? Okay, all right. Why might that method 2 give us, for some reason, the wrong answer? Okay, well, really, there's a couple of issues with this, okay? When I was answering this question, I kind of said that it's quite difficult to tell. If we're pouring a liquid in to a glass, or a test tube in this case, it's quite difficult to tell if it's full. Okay, it's not something which is very, very easy to tell simply by looking at something if something is full, because you always find, and there's various videos of this kind of thing, that you can add more water to something. All right, there's also a meniscus issue here. okay, and the fact that we might spill some water. So to be honest, when I was writing this question, I think I got a little bit carried away. Okay, I started thinking of lots of reasons. We've got an issue with water spilling, we've got the meniscus, and we've got the fact it's difficult to tell. Now, you only need to have one of these. I would discourage you from doing a me and writing everything. Why not choose one? Okay, so we've got the idea of the test tube not being completely full. Maybe it's been overfilled, it's been spilled when we transfer it, so we think that we've lost some water there. Okay, we're not reading at eye level, okay, etc. There's a lot of issues here. Choose one. Maybe do as I say, not as I do. Okay, I'm not sure if I would get the mark here. Maybe they think I'm being a bit over the top. Okay. We then want to think about figure 5.1. We want to suggest why V in method 1 is an overestimate. Okay, so specifically an overestimate. Let's have a little look here. Okay, I think it's worth having a look at. Go back, and the question does say look at fig 5.1, so let's look at it first. Okay, if you notice here, we've assumed something about the shape. Okay, we've assumed that our shape is uniform throughout this process. In other words, we've ignored this little green shaded bit here. Okay, and what we've done there is by doing that, we're kind of chopping off a little bit of the volume of our test tube. And so what we're doing really is we're ignoring the fact that it has a rounded bottom end. Okay, it doesn't allow, we don't really have anything in there which accounts for that bottom end, and so therefore actually we're going to overestimate. We're going to make it a little bit too big. Okay, if you see here, overestimate because it has a rounded bottom. Okay, and there's another couple of reasons. One, we've measured the external volume. Let's have a little look there. Come back here. Our dimensions actually have been measured to the outside of the test tube and not the inside. If we really wanted to know this value, what we should be measuring is this value of D here. And that's what they mean here by overestimate, because the external volume is found. Okay, it means that actually we've looked at the outside of the tube and not the inside. Okay, all right. I think that's enough for this question. Again, pretty nice one. A couple of bits of measurements, a couple of calculations, and a bit of a discussion. 9 marks there. Okay, I think we can shoot for a fairly high score on this one, guys. As usual, questions, ask them. Thanks for watching.